Dear viewers, good afternoon. My name is Zhang Congjing from China Media Group. I'm right now on a vessel of Maritime 720, which is the largest of its kind for marine exploration. And right now, some seabed exploration is underway, and we have worked out the 3,000 meter deep topography drawing, and this is like a treasure map of the seabed, because with this map, we are able to know the topography of the seabed so that we can identify oil and gas resources. So today I'm going to take you on a tour on this, and let's try to find some treasure. So this is the equipment room, and this is where the treasure map is born. Hi, say hello to our viewers. Good afternoon. I'm the deputy manager of Vessel 720. So you're going to take us on a tour of this treasure hunt and tell us more about it. So where is the map? It is here. So it may look very ordinary, but actually in it there is a lot of treasure. And he's the drawer of the map. His name is Hui Hongbin. So good afternoon. I can't wait to take a look at this treasure map, and I'm holding my breath. All right, let's unfold it. So I can see a lot of patterns. This is like a ancient Chinese painting, and it's very long. I need some help here. So now you can see this is the first 3,000 meter deep topography map of the seabed. And as you mentioned, this is like a Chinese painting. And when I see this map, I wouldn't tell where the treasure is. Well, this is at the depth of 3,000 meters. So the seabed is just like the landscape that we have on the land. And there is mountains down there, and there's also valleys. So tell us more about it. So this is the sea level. Yes, this is the sea level. And this is actually the seabed, the red line. So from here is actually the north, and to the right it's south, and it's going down. So you can see it's a gigantic slope. So this is like the continental shelf, the extension of the shelf, and you can see that we have a timeline which is 4.4 milliseconds. So it's actually more than 3,000 meters deep. So this tells us the topography. This helps us to understand the topography of the seabed, and I see a giant slope, and you unleashed one very important piece of information, and the actual depth is actually 3,500 meters. So we have the topography here, and what else? So there is a scale of this map. So this is a very long scroll. This is the section view. And actually this is telling you the topography of the seabed, that is 41 kilometers. So this is the scale, and if it is 1 meter deep here on this map, it's thousands of meters deep in reality. So if you time the speed by the times, that gives you the total number of depths. And the deepest point is 9 seconds, and that is 16,000 meters. So you're telling me that this is 16,000 meters deep. exactly. So this is the depth from the sea level, and we're able to tell what is the topography that is 16,000 meters below the sea level. So this is a section view of the seabed, and this is the first time that we have gone this deep. And also, with the help of geologists, we can further understand this map and get to know more information. So this is the section view of this topography drawing at the depth of 16,000 meters. So you see this is the treasure map, and tell me where the treasure is. Well, we're gonna get some professional, and we are looking for the patterns and structures of the seabed, and where are the fractures, how they evolved, and where the oil and gas are hidden in this map. So through this map, tell us what are the structures that you have identified. So you see there are a lot of patterns here, and this is one curve here. So this is telling you that we may have some oil and gas hidden here, and there's another line here, and one more here. So through this map and through the introduction of Mr. Guo, and there are a lot of curved lines. You see we have 3 and 4 such lines. And does that mean that there's treasure in there? So this is actually a interdisciplinary study, and we have physicists, we have geologists. They can work together to tell us what those colors indicate, and not all those curved lines indicate a layer of oil and gas. And maybe there's a lot of mineral resources, and maybe there is high potential of oil and gas resources. So this is just the first step, and you need to study the structure. And after identifying the structure, this does not guarantee the resources of oil or gas, and you need to further analyze the level of salt. And then we're gonna put a drilling hole there, and then take out some of the samples, analyze the color, and then it will tell us what is buried beneath the seabed. So I can draw a conclusion that it's not that easy to find the treasure simply with this map, and you will need to put together a team of geologists and physicists. So this is laying the groundwork for future search and exploration of oil and gas resources. Well, to me personally, this is a very rare and valuable material, because we can know what is beneath the seabed, and we know the different colors of the structure. So we are able to collect all the signals together, and then we're going to hand it off to geologists. I think they're going to be equally excited, and with this groundwork, we can start our exploration. And this is just like comparing a MRI image and CT image. And if you are the doctor and you know the difference, and I can tell how proud and how excited you are, Mr. Guo, and we as outsiders, seeing this firsthand, we don't know what it stands for, but we know that there is something in it. We're very excited. As you mentioned, that this is not just something that you can work out with several people. This is the collective result of a team. And yes, we have been working as a team. We have a collection team, we have an analysis team, and so this is truly something remarkable. Well, this is a 2D drawing, and a lot of us are asking what would it look like if it's 3D. Well, we actually have a 3D printer here, and we can show you how it looks like in 3D. Well, it's currently printing the topography, and it's currently working on it. And you can see from the north, we have a slope that is very deep, very steep, and then we have another slope in the south, which is not so steep. So basically, we're using this 3D printer to give you a 3D view of the topography of the seabed. So you can see that the pattern or the topography at the seabed is very sophisticated. And I can see you have another 3D model here, and tell me more about it. All right, let's put it here. So we have done a lot of digital modeling, and this is the overall view of the seabed. It's highly consistent to the data that we have collected. And this is at the depth of 3,500 meters. And let me show you. So this is the 3D model of the seabed. But we have showed you the 3D, the section view. So, well, let me open it and show you the section view. All right, so we saw a 2D map, the treasure map, and we collect a lot of data, and then we're going to hand it over to geologists, and they're going to further analyze the data. They compare the different colors of the drills, and you can see that they can tell the difference between those rocks. And they're going to conduct a lot of mathematical and geological studies of the seabed, and then they know whether it is mud or mineral resources. So that is the second step of the work. Our scientific workers and geologists, they're going to work together to analyze what is buried beneath the seabed. Thank you very much for sharing with us. So we learned a little bit of how to identify the treasure, and you also showed us your 3D modeling system, and I think this is very exciting. Yes, indeed. So this is independently drawn by China's sea wheel system, and so tell us more about the sea wheel system. The core members of the sea wheel system, and let me introduce Chief Engineer Hao Lan. Well, we feel very excited after seeing this map, and tell us how you came up with this map. Well, thank you very much for introducing me, and you saw the map, and it's very delicate, very sophisticated, and we need some very sophisticated equipment, which is the sea wheel equipment. Well, I have been on this ship for a couple of days, and we have seen a lot of cables, and those are very large equipment. So why you bring us here to this equipment laboratory? Well, as far as the sea wheel system is concerned, it's actually very big, and we have equipment outdoors, and we also have equipment here indoors. And this is like the control room, and we do not work every day outside, and we have to do some researches here at the control center because this is the brain of the system. Very well said. And so you have a map in your hand, and tell me more about it. So this is how our system works, and we have 4 subsystems. This is the seismic control system. It gives you seismic waves. So this is the collection system. which is able to receive the seismic waves and signals. And this is the location system, and because this is connected to all the cables, and we can control the distance between the different cables and then analyze the depth of the cables. And then we have another monitoring system. This is like the control center of the entire system, and it's able to coordinate the different systems so that we can provide the very accurate time and location information. So these four subsystems, they work collectively together as integral parts of the sea wheel system. So in this room, where are those systems? Are they running on your computers? Some of them are in a cabinet, some of them are outside, and you can see that this is the control interface of this seismic wave generation system. So these people, they control when and how those seismic waves are sent out, are generated. So we are analyzing the waves that we send out and we collect. And here on this side, we can show you the topography analysis system, and we can receive all the different waves and signals that we send out. And we have more than 5,000 test points on each line. This is like a detector that is able to draw and show you the inner structure of the seabed, and we show you all the different signals that we received, and then we put them together and work them into a map. And we are able to monitor the operational status of the cables, because those cables, they are deployed in the seawater. We'll not be able to see them, but we can analyze their status by collecting their seismic signals. And what else? To this side, we have the navigation team. So we have the control and location system. This is the geological positioning system. So tell us how you control that. So this is the control interface of the positioning system. And we are able to tell the specific position of every mark. So the blue color indicates that it has exceeded our theoretical depth acceptable. The red colors indicate that we have lost signal contact with those marks, meaning we have to replace those systems. Those marks, they are running on lithium batteries, and if we identify a lack of battery power, and we're going to dispatch our people down there to replace the battery. So when we send a submersible down there, they know where to find those sections of the marks, and we also know the exact depth of those marks. So this is the interface that controls the intervals or distances between different markers. This is like the brain of the navigation system, and so we all have a digital map on our phone, and everybody understands a little bit of the navigation system. So this is just like the navigation map on your phone. It is able to tell you the specific position of a marker. It can also tell you how to navigate to the point. So what are those circles? What are those circles for? So this is the navigation route that we have planned, and it can be transmitted to the control interface on a real-time basis so that we can set a navigation route so the helmsman knows where to navigate and how to navigate to the point. So this is very well coordinated, and we feedback this information to the driving cabin, so we know where to find those markers. So this is the system behind everything, and you know where and how to collect information. And you saw a lot of control softwares, and the controllers and the servers, they are placed right behind those glass doors, and you can actually take a look. Wow, it's a lot of noise and it's very cool. The servers, they are running 24/7. They need to be guaranteed with the low temperature and dry environment. So these are the server cabinets. So this is showing you the current depth of the water, which is 3,345.85 meters. And all the servers of the sea wheel systems, they are here. And this is the navigation system. To the left, we have the seismic wave generation system. We have the wave collection system, and also the fault generation system. And after the information is collected, they will be stored here. This is just like tapes. Well, in our real life, we don't use this anymore as a storage disk. But this one is able to accommodate 500 gigabytes of data. And for every system, we have two copies, one original and one copied one. So this is simply to ensure the safety of data. So we haven't seen this for a while in the real world, and it is quite surprising to learn that you're still using this very conventional way of storage of data. And you said that this is very big. It can hold 500 gigabytes of data. But let me ask you, how much data that you can collect every day? Well, it depends on where you are. Here at this part of the sea, we can accumulate 500 gigabyte to 1 terabyte of data, and we have data processors, and they can further process the data. At the end of the day, they are going to give you a section view. So all these tapes, they are from this mission. Not entirely. These are telling you part of the data. We have the original disks and copies, and they are well juxtaposed. This is simply to ensure the completeness of all the data. So this is not a big room, but truly it's playing a very important role. So you're one of the core members of the research and development team. Tell us, how long did you go to develop this system? We actually studied from 2002, and to this day, it has been 20 years. So how do you feel seeing your own system and that is playing a very important role? I feel very excited, and the system is just like my baby. Thank you very much for telling us more about the treasure map, from R&D to application. So this is truly remarkable, and we have been working on this for 20 years, and it's a remarkable journey. So we have already delivered the first seabed map, and you said that you're covering more than 25 million square kilometers, which is truly amazing. And you said that you have teams to cover more areas. So this is the control interface. May I invite Zhang Wei, our equipment engineer, to tell you more about the control of the devices and equipment. So what is your daily work like? So we are controlling the deployment of those underwater equipment and also the maintenance of those equipment. We conduct day-to-day maintenances to identify problems. We're like a cow. We have to work on the farmland, and we also need to sow the seeds at the farmland, and we also monitor the growth of those plants. Well, yesterday I think at the live stream program, you were driving those little vessel, so you're playing multiple roles here in this team. Well, we have to do this, but mainly I'm working as a equipment engineer. So as an equipment engineer, we have to work multiple roles. We need to maintain and update those equipment. You have to be on it 100%. You need to have a work plan, and you need to analyze and identify the hazard and defects of the systems. So that's why I have to drive the vessel to the point of dysfunction. So this is not entirely, this is not what your job is all about. So you have to truly play different roles. And all right, this is the equipment team. What are those people doing here? So this is the navigation team, and they plan the routes ahead of us, and they tell you what is our next point is. So Mr. Wang is the head of the navigation team. So this is truly a very large vessel, and you decide where it goes. Yes, and as was mentioned earlier, we have a very sophisticated navigation system. We are making a lot of turns. So why we have to take so many turns? And there are a lot of precautions, and sometimes we have very sophisticated work conditions. There are obstacles at the seabed. We have to circumvent those obstacles. Also, we have to improve our efficiency. We need to spend the minimum time and then cover the maximum area of the seabed. So we're just like a painter. This is like our brush. So each and every time we can only scan a limited portion of the area, and after covering this width, then we have to take a turn and come back, and we have to repeat this route. At the end of the day, we're able to cover the entire zone. So you can see that all the blue-colored zone is a space that we have covered. So this is simply to say that we have finished scanning this area. All right. Thank you very much, General Manager. I got to know the different parts of your team, and I got to know how you draw this treasure map. So this is the result of collective efforts from all the sub-teams, and over the past month, we have encountered some challenges. Well, because this is the first time that we are covering such a deep area. And so my colleague is going to tell you more about it. So it's been a month, and this is the first time China is drawing the treasure map at a seawater with such depth. So this is the first time we are conducting an exploration for the seawater that is 3,000 meters deep. And last month we encountered a typhoon, and that delayed our schedule by 6 to 7 days. So weather is one very important influencing factor. We have to pay attention to the weather, because our work can be impeded by the weather. We learned today that we're going to be affected by another typhoon. very soon. Yes, I have been following that typhoon, and you can see this is the drawing of the routes of the typhoon. You can see where it's going to go in the next few days, and we have to avoid the routes of the typhoon. Well, I want to know because we are operating on the sea. If we ran into typhoon, what are our countermeasures? Well, each time there's about to be a typhoon, we're going to take some precautions. Well, specifically, we have to circumvent the typhoon. Well, we're not talking about one boat. We're talking about a great number of cables and equipments, and we're dragging those equipment. But how can we ensure that we're speedy enough? So we have 10 cables, each with a length of 8 kilometers. So it's very long. So when we have to avoid the typhoon, we have to take back the cables, and then at the same time navigate our routes so that we can avoid the typhoons. So what are the other challenges that you have encountered on this mission? So we also need to take into consideration the overall maritime navigation. Take a look at this is the thermal drawing. The darker the color, the more active the zone is, the more ships there are on that sea. So we have to avoid colliding into those ships and vessels because sometimes the ships they have to sail above our cables, and we have to make sure that they do not damage our cables, and we have to ensure the accuracy of the data. And when there is the ship sailing above the cable, the data will not be accurate. So we have to delete that portion of the data. We have to communicate well in advance with the ships. If the result of the communication is not very ideal, we have to delay the operation. We have to postpone the operation. So navigation on the sea is one very important influencing factor for our mission. So I assume that fishing activities are the third influencing factor. Yes, exactly, and this is telling you the fishing boats of China. Each and every dot is one fishing boat, and we can show you the specific location of those ships on a real-time basis, and they can affect navigation. They can also affect our measurement because they are dragging a very big net, and we are also dragging a very long equipment of cables. And when we are scanning a certain area of the sea, and sometimes we can be approached by a small fishing boat. So how do you avoid this kind of situation? So we have 2 or 3 boats that are accompanying our vessel. So their job is to keep in close contact with those small fishing boats. So we try to avoid this kind of situation. Well, I know that you have to very accurately control the equipment. You need to also avoid the influences of other factors. Well, I feel that this exploration mission is very challenging and it's more difficult than I anticipated. So this is telling you how much effort we have put into this mission. Let me share with you some of my own observation. So Marine Oil 720, since the mission was launched in 2002, we have covered 4 major zones. We covered more than 4,000 square kilometers. We have reached exceeded the global standards. So we're using made in China equipment, So how to compare made in China equipment and equipment made by other countries? I think ours are much better, and I'm very proud of that. So those equipment, they were independently developed last year. Is that right? Yes, and they were rolled out only last year, but prior to that, there were many different rounds of iteration at the laboratory. So how many years have we been working on this? 15 years. I studied my work in 2008, and in the first 14 years, we have been using imported equipment. Starting from last year, we have been using our own equipment. It's super convenient. In the past, you need to spend a lot of time purchasing those imported equipment. The maintenance cycle is also very long. And now we're using made in China equipment. So it's super convenient, and in the future we're gonna further update our system, and we're able to tell you exactly where those treasures are. So we got aboard this ship on September the 27th, and we witnessed this gigantic project and the major breakthroughs made by this mission, and we are more than proud of this achievement. And China is going deeper and deeper in terms of sea exploration. Thank you very much for following our program. We are on board Marine Oil 720, and thank you very much for watching. So this is China's first exploration at the depth of more than 3,000 meters, and we have been updating you on this exploration mission. So how come we have live stream signal at such a very harsh environment? We have actually a team for signal transmission, and later we're going to show you more about the signal team. For this live stream on the sea, the team has given us one small studio. This is like a studio on the sea, and we have some members from China Media Group. We have cameramen, photographers, and journalists. So this is our studio. It's not very big, but we have everything. So say a few words. So this gentleman is the photographer, Mr. Xu. Thank you very much for working so hard. Give us a brief introduction of this studio room. So you can see that this is our live streaming team for this mission. So you are seeing different images and footages, and this is the image switcher. And then you see a lot of cables, and some of them are connected to deck number 7, and deck at the 7th floor. And they are connected to all the different cameras. And this is the last session of our team. And we have completed all the photography work. We have collected all the equipment. And let me introduce my colleagues. And this gentleman is in charge of all the mics, Mr. Jiang. All right, say hello to our viewers. And we have been working on different audio channels. And Xiaogu, another of my colleague, and the in charge of signal transmission. And truly, this is very incredible. And those are the unsung heroes behind the scene. And we have a lot of killing technology. And can you tell us more about those equipment? Take a look at the equipment on the table. We have a live streaming system for that because we are on a ship. We are working together with some helicopters. So this equipment, they are very portable. We have so many equipment here. And give us some introduction. So our viewers, they are very much wondering how we keep in touch with our family. We don't have SIM card. Even if we do, there's no signal. So we have 3 satellite phones. So we're getting in contact with the studio room at the China Media Group. And take a look at this one. This is a magical tool. The green color one, this is like a tortoise. So this is actually a drone underwater. A lot of the very beautiful footages that you see underwater are actually taken by this thing. And what is that? That is the control console. And we use that to control the navigation and operation of the underwater drone. And this is the UAV used by our aerial footage team. So this is the UAV flying in the air. We have to elevate our camera to the air. And so where is it? Well, I apologize and sorry to tell you that that one was sacrificed. It sank into the seawater, and we were not able to recover it. And those are the different audio signal tools. We have a lot of control boxes. For example, this one is connected to all the cameras, and we can send a signal to the central control room. And we have also a few mics, and you can speak into the microphone, and the sound is going to come directly into the studio. Take a look at this camera. And many people say that this is like a roaster because the head can turn around, but it's very stable and steady. When we are taking some moving objects, it can give you a very steady picture. Over the past 3 days, I think you have gained a better understanding about this mission, which is the first time China is conducting a sea exploration at the depths of 3,000 meters, and we have brought out the first treasure map from the depths of more than 3,000 meters, and we have verified our capabilities. And through the live streaming program, you have seen with your own eyes those major breakthroughs, and we have actually got on board on September 27th. How time flies! It's been a week already. Thank you very much for staying with us during this National Day holiday, and we are coming to the end of this program. So, Mr. Xu, thank you very much. So what you now see is a very tiny studio room with not so many equipment, and our cameraman is holding the camera right now, and he's the unsung hero. And let me switch this camera a little bit so you can see our cameraman, Bo Feng. And can I bring Zhang Bo here? So right now on this screen, you can see everybody behind this program. And let's come together. And this is Zheng Nan, the navigator of our drones. All right, let's say a goodbye to our viewers. Until next time, bye.